Hi and welcome to the first lesson in the debugging series. A debugger is a program that allows to inspect and analyze other programs dynamically. For example, we could stop a program in the middle and see or change the contents of the memory, registers, and more. A debugger helps understand what is going on inside the program, and it is very useful to solve problems and bugs inside your program. In this lesson, we are going to begin with a very simple example, and we are going to use WinDBG as a debugger. We begin with an example just to make sure that you have a feeling about what is a debugger before we begin speaking about debuggers generally in a more formal fashion. Don't worry if at this point you don't follow everything completely. Everything will be explained later. Let's begin by looking at the program memcount.asm. It is a pretty short and simple program. Mostly it has an array in the BSS section, and the program itself is about filling this array with numbers. Let's follow the program for a moment. We initialize ECX by the size of the array, and we also zero EAX. Then we load EDI with the address of the array. Next we have a pretty short loop. In every iteration, we store one dword, which is EAX, inside the array. Then we increase EAX, and finally we move on to the next iteration, which means that we are going to store the numbers 1, 2, 3, 4, and so on into the program. This is basically what this program does. A pretty simple one. We are going to follow this program, or maybe the execution of this program, inside a debugger to see how it works internally. This is going to be a good introduction to how a debugger works and how to use a debugger, at least simply. Let's save this program. And now we assemble the program. The assembly went successfully. If we run the program, we can see that nothing really happens, and that is because we didn't really have any output in this program. It just stores some numbers into the memory. Basically, running this program is not really interesting. Let's try to open it with a debugger. I'm going to use the WinDBG debugger. I know that you haven't installed it yet. It's not a problem. In the next lessons we are going to discuss how to install WinDBG. But first I just want to show you how it works. Note that I have two different versions. One for x86 and one for x64. As my program is 32-bit, I'm going to choose x86. x64 is for 64 bits. This is WinDBG. I have to admit that this program is not much of a graphical user interface program. Maybe at first sight it looks not really cool because it is pretty gray, and soon you will also see that it is mostly a command line program. However, in the future you will find out that this is one of the most powerful tools that you are going to have. Therefore, I really recommend to use the WinDBG debugger if you are going to debug inside Windows. We've already assembled memcount.asm, so we got an executable file. I'm going to open the executable file inside WinDBG. I click File, Open Executable, and next I'm going to copy the path of the executable file. I paste it here, press the return key, and then choose memcount.exe. WinDBG will sometimes ask you questions which are mostly cosmetic. For example, save information for this workspace. At this point, we don't really care about those things, so usually I will just click no automatically. Let's see what we got now. We can see that this is the memcount.exe program. However, it is waiting, which means that it is currently paused. The program has begun, but it is paused. This is why it hasn't exited yet. It hasn't terminated, because it waits. The program has already begun, but it waits in the beginning. It is paused. We also got this new strange white window, which is part of WinDBG. The first thing which we are going to do is clip this window to the bigger window. There are lots of things which are written here, and at this point you might not understand all of them, and this is okay. Currently, mostly what we can understand is this part. We are given the values of many registers, and also of all the flags, and maybe some other things that you haven't seen before, and that is okay. What this line tells us is that the program is currently paused on this strange instruction called int3, which has the encoding CC. Let's open the disassembly window, which is going to show us the current code. Now we have two windows. We have this one, which was the window we had in the beginning. This is where we write our commands. And we have another window, which is called disassembly. This is where we see the current code. Basically, we can see that currently EIP points to this instruction called int3. We've already seen the program memcount.asm, and we know that we haven't wrote this code. This code doesn't belong to us. If you were wondering where did this code came from, this is a code which belongs to the operation system. It runs before our program runs. Basically, it just prepares some things before we can begin our program. We don't really care about this part. Therefore, we are going to do something interesting. We are going to add something which is called a breakpoint in the beginning of our code. We are going to do it using a command, bp exe enter. This is not an instruction. This is a command to WinDBG. This is how we communicate usually with WinDBG. We can use the menus and some of the buttons, but we can also use commands. Don't worry about this command right now. You just have to understand that it allows us to stop exactly in the beginning of our code, which is basically this instruction, move ECX rlem. This is where I want to stop. I don't really care about this code because I didn't write it. I press the return key, and now I got a breakpoint in the beginning of my code. Next, I'm going to use the G command, which is going to resume the program. I remind you that the program is currently paused. It is not doing anything. It just waits. If I want to resume the program, I have to use the G command. Now I press the return key. I can see that something has changed inside the disassembly window. I got to a different piece of code, which is the code that I wrote. As you can see, this part move ECX 20 and then XOR EAX EAX and so on is exactly this code. Move ECX RLN, XOR EAX EAX, move EDI MyR and so on. You can probably notice that the syntax has changed a bit because WinDBG uses a bit of a different syntax. This is not the FASM syntax. But this is okay. At this point, you really know assembly language. You will probably be able to understand any syntax that you are going to see. Another question would be, how did we get to this code? What did really happen at this point when I wrote G and then pressed the return key? Let me describe what happened. Remember that before we added a breakpoint at the beginning of the code. Basically, we added a breakpoint here at this point. Next, we resumed the program. The program just ran as usual, and when it got to this instruction, to this location in the code, it stopped immediately, and then gave us back the control. Currently, the program is paused again, and it waits for us. It waits for the debugger to do something. The debugger actually has control over the program. What can we do at this point? At this point we can step, for example, the program and see the contents of the registers, or maybe the contents of the memory. It might be interesting. How can we do it? We have this menu and it contains a few interesting buttons. One of them is called Step Into and another one is called Step Over. Basically, we are going to use those two options to travel inside the code. Those are the basic two options. There are, of course, shortcuts to do them. For example, Step Into could be done using F11. And Step Over can be done using F10. We are going to discuss the differences between those two later. Let's begin by stepping a bit. I'm going to use Step Into. As you can see, we moved from the first instruction to the second one. Next, we move to the next instruction. As you can see, every time we step, we are presented with the values of all the registers. For example, just after the XOR EAX EAX instruction, we can see that EAX has turned into 0. But before this instruction, EAX had some strange value. Let's also continue with this instruction. Good. By the way, the red part is where we have our breakpoint. This is how breakpoints are marked. Currently, as you probably remember from the code, we have inside EDI the address of my array. Let's open a memory window to look at the memory at that location. View, Memory, and I get this new window. Now I have three windows, one for the code, one for memory, and one for the commands. I know that currently EDI contains the address of my array. Let's see what is the contents of EDI. EDI contains this value. By the way, I used the R command to show the contents of EDI. This is the address of my array. I'm going to copy this address and paste it here. Now I can see in memory the location 401 followed by 3 zeros, which is the address of my array. Basically, my array is here. Next, we are going to follow what happens when we run the code. I'm going to step into every time, and we're going to see the changes to memory. I remind you that this program just writes increasing numbers into this array, increasing D words. We can see that we already wrote the first D word, which is 0, and the next one, which is 1. Let's continue a bit. The next D word is 2. Note that the numbers are represented in the little endian convention. And this is the next number, 3. If we wanted, we could present the information in a different format. In this case, maybe choosing long would be better, because all the numbers are D words. As we can see, the first D word is 0, the next one is 1, then 2, then 3, and so on. We continue more, and we get 4, 5, 6, and so on. You might get tired after a few clicks, mostly if the loop is much longer. This loop is not that long, but imagine what would happen if this loop would be of size maybe 10,000. It will be very unfortunate to click 10,000 times. Instead, we can just put a breakpoint at the end of the loop, and then let the program resume. At this point, it is paused. We can let it resume, and then we will find ourselves outside the loop, and we can see the effect of this loop without having to iterate ourselves. So let's add a breakpoint. We can say that the first instruction after the loop is this instruction, push 0, which is really this instruction. Let's copy the address of this instruction and put a breakpoint at this address. As we can see, we have this red line, which represents a breakpoint. Now, instead of stepping into, we can just use the G command to let the program resume. It will then run as usual until it gets to a new breakpoint, which will be probably this breakpoint. I wrote G, and now I press the return key to give the command to WinDBG. As you can see, I got to this location, push 0. Another thing which we can notice is that the loop has ended and all the numbers are written to memory. Breakpoints are really powerful tools. So far we've seen our ability to step through instructions and also the ability to put future breakpoints and then let the program resume until it meets a new breakpoint. As we can see, the next instructions are push 0 and then call to some strange location, which we know that it is exit process in our program, which means that next the program is going to exit. Let's resume the program and let it exit. We can see here NTDLL, anti-terminate process. The process is ended. Basically, these are only the really simple things that we can do with a debugger. And especially when talking about WinDBG, there are much more advanced things that we can do. We are going to learn a bit later about installing and using WinDBG. If you didn't follow everything in this lesson, don't worry. We are going to discuss everything in a very detailed manner. See you on the next lesson.